Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi guys, this is the new chapter, chapter 2, atomic structure. There are 3 hours of lecture and 12 hours of tutorial session. For the first video, you are going to look at the first subtopic 2.1 Bohr's atomic model. The first 2 learning outcome that you are going to learn is describe the Bohr's atomic model, explain the existence of energy levels in an atom. There are 3 Bohr postulates about Bohr's atomic model. The first one is electron moves in circular orbits around the nucleus. The electron does not radiate any energy and does not absorb any energy. Here, the red one is the nucleus and the electron will move circular orbit around the nucleus. While the electron moving, this electron will not radiate any energy, maksudnya dia tidak akan radiate ataupun dia akan membebaskan energy, and this electron also will not absorb any energy. That means energy dia constant. If this one is the nucleus and this is the electron, sepanjang dia moves around the nucleus, energy dia fixed, energy dia tetap. That's the first thing that you have to know. The second one is the energy of an electron in hydrogen atom is quantized. It means that the electron at certain distance from the nucleus can only possess a specific amount of energy. In other words, an electron can only move in a specific orbit or energy level around the nucleus and not in between the orbits. Okay, so for the second postulate is this first sentence. I did mention the first one, electron mengelilingi nucleus and this electron not release energy nor absorb energy, right? And the second one, dia nak bagi tahu bahawa the energy of this electron yang moving around the nucleus is quantized. Okay, what is quantized? That means you can calculate that energy, alright? And also, it's also mean that bila electron tu berada dekat a specific orbit, okay, or specific energy level. After this, if I mention word energy level, itu bermaksud orbit. Orbit nombor 1, orbit nombor 2, because you learn orbit, right? So here, I'm using term energy level. Kalau dekat certain orbit, okay, contoh dekat orbit nombor 1, maksudnya energy dia is specific. Memang itu je energy dekat orbit nombor 1. For the electrons at orbit number 2, okay, or energy level 2, okay, dia punya amount of energy adalah that certain amount, the specific. This is the second Bohr postulate about atomic model. The third one, energy is emitted or absorbed by the electron only as the electron changes from one allowed energy level to another. This energy is emitted or absorbed as a photon. The electron, when they are moving from one energy level to another, it's either they are absorbing or emit ataupun release. For example, okay, the diagram on the left, the electron is moving from n equal to 2, okay, mean dekat sini level 2 to n equal to 3. Okay, when the electron moving from lower energy level to higher energy level, okay, the electron will absorb energy. Okay, on the other hand, when the electron moving from higher energy level down to lower energy level, the electron will emit or release the energy. This energy that release, dia akan dalam bentuk photon, which is cahaya. You akan nampak cahaya lah. These 3 are the Bohr postulate. Maksudnya, idea Bohr's is not only on his opinion, but based on his research, what he found, what he can come out about atomic model. Next learning outcome, it is calculate energy of electron. This learning outcome is referring to the second Bohr postulate, which is Bohr ada bagi tahu bahawa elektron yang mengelilingi nukleus, kita boleh kira dia punya energy dan energy dia specific at certain energy level. So, this learning outcome nak ajarlah macam mana nak kira that amount of energy. This is the formula if you want to calculate the energy of an electron at its level. Okay, this one is referring to the second Bohr postulate. Energy level nombor 1, berapakah energy yang elektron tu ada. The formula is En equal to negative RH in bracket 1/n squared. Okay, RH is Rydberg constant. Okay, the value you tak perlu hafal. You just have to memorize this formula. The value of Rydberg constant, you can just refer to the list of constant values. Okay, N is principal quantum number. This one is also referring to the orbit of electron. Electron tu, you nak cari electron tu berada di energy level yang mana or orbit yang mana. That is N. Okay, the electron nearest to the nucleus has the lowest energy. Maksudnya, logically, bila elektron tu makin dekat dengan nucleus, energy dia should be bernilai sangat negatif. Okay, dan bila you makin menjauhi nucleus, nilai dia akan ke arah zero. Sebab dia bebas, dia tidak terikat. The third point, energy is zero if electron is located infinitely far from nucleus. Semakin jauh dia dengan nucleus, semakin ke arah kosonglah nilai dia, sebab dia tak terikat, dia bebas untuk bergerak maksudnya. Energy with negative value means the energy of an electron in an atom is lower than energy of free electron. Okay, an electron which is free from. Okay, so kenapa? Sebab bila nilai dia more negatif compare dengan nilai yang kosong. Nilai yang kosong maksudnya dia ada energi yang banyak lah, sebab energi dia bernilai kosong compare to energi yang bernilai negatif. Bila energi dia banyak, bermaksud dia bebas bergerak. Okay, itu maksud the last point. Question 1. Calculate the energy of an electron at energy level n equal to 2. We are referring to this electron. First, you have to write the formula. Then, what you have to do, you just substitute the value of n with number 2 because we are referring to the electron at energy level 2, and then you substitute the Rydberg constant, refer to the previous slide, or you can also refer to the list of constant values. Then you will get answer is negative 545 exponent 19 joule. Okay, because energy, the unit for energy is joule. Please write correct unit. Proceed to the next learning outcome. Okay, there are 3 learning outcomes that I'm going to explain after this. The first one is describe the formation of line spectrum of hydrogen atom. The second one is illustrate the formation of Lyman-Balmer partial bracket and Fun series. E, dia ada kaitan dengan ni lah, line spectrum described at learning outcome D. And the last is calculate the energy change of an electron during transition. This learning outcome F is referring to the third Bohr postulate about atomic model, which is when the electron moving from different energy level, there will be energy emitted or absorbed. So this learning outcome will teach you how to calculate those energy difference. Line spectrum ni dia ada kaitan dengan the movement of electron. Okay, when the electron moving from different energy level, maka dia akan menghasilkan line spectrum. Line spectrum is a spectrum consists of discontinuous and discrete lines. Okay, discontinuous maksudnya line ni satu line ada gap, tiba-tiba ada satu line. That is mean by discontinuous. Discrete line maksudnya line yang halus sahaja. Itu maksud dia. Okay, each line corresponds to a specific wavelength or frequency. That means you can calculate line warna merah, the yellow, their wavelength and frequency. This slide explain the difference between line spectrum and continuous spectrum. Okay, supaya nak bagi nampak. Okay, this one is the line spectrum. Okay, yang awak belajar. Ni continuous spectrum. At continuous spectrum, warna dia bersambung. Bersambung daripada awal sampai habis. Kalau yang ini pula, dia berada di kawasan yang sama, wavelength yang sama, cuma kita hanya nampak discrete line. Kita tak nampak benda tu bercantum. Sebab itulah dia adalah discontinuous tadi, the previous slide. This one is line. That's the difference between line spectrum and continuous spectrum. Continuous spectrum yang paling senang nak nampak adalah pelangi. Pelangi itu adalah salah satu contoh continuous spectrum. Kan awak nampak warna pelangi akan sentiasa daripada merah dan seterusnya. Itu adalah contoh continuous spectrum. Another additional thing yang saya tambah is how to get line spectrum. Okay, seperti chapter 1, Madam ada cerita how mass spectrum terhasil. Ni Madam nak cerita macam mana hasilkan line spectrum. Ini adalah satu tube. Tube ini kita akan letak sebab line spectrum yang awak belajar specifically is for hydrogen atoms. Okay, so kat sini ada banyak hydrogen atoms. Okay, bila litas sudah lengkap, maka hydrogen atoms di dalam discharge tube ini akan menerima energi yang lebih. So awak dah belajar kinetic teori bahawa bila dia terima energi lebih, maksudnya dia absorb the energy. I'm using this slide as example. Contoh hydrogen ke elektron dia dekat N equal to 1 kan. Ni elektron dia. Kan tadi di dekat discharge tube, lita lengkap, dia absorb energy. Dia absorb energy. Maka bila dia absorb energy, elektron yang ada pada hydrogen itu dia akan naik ke higher energy level. Energy level berapa? I don't know. Because setiap hydrogen atom, they might absorb different amount of energy. Saya tak kata, semua hydrogen atom ini akan absorb sebanyak 100 kilojoule. Tidak. Okay. Setiap hydrogen atom ni mungkin akan absorb energy level, different amount of energy. Maka elektron, semua hydrogen atom tu, elektron tu agak bergerak ke higher energy level yang berbeza for setiap hydrogen atom yang ada dalam discharge tube ini. When the electron reach higher energy level, for example, dia berada dekat energy level ini, contohnya sini contoh. Dia berhenti kat sini lah. Dia absorb a specific amount of energy and the electron move to the n equal to 4 contohnya. When the electron at n equal to 4, electron tu sebenarnya dia very unstable. Analogi dia, tak tahulah kena ke tak analogi yang Mida nak sampaikan ni. Contoh macam orang kata memang betul pun, okay, kalau budak-budak kecil orang bagi banyak benda manis, makanlah gula-gula lah, coklat, nanti budak tu dia akan dia punya aktif dia lain macam tu lah. Mida nak comparekannya dengan elektron ini. Tiba-tiba dia menerima certain amount of energy and suddenly dia excited. Dia excite ke high energy level. Bila budak-budak dah terlalu aktif, kita yang orang dewasa ni akan macam, okay, tenang sikit, jangan nak aktif-aktif sangat, macam tu. So budak tu dia akan dah main-main kan, nanti kita macam, okay, dah tenang, aktif sangat nanti penat, macam tu. So macam tu juga dengan elektron. So bila dia dekat atas, dia sebenarnya dia very unstable. So what the electron have to do, elektron tu akan release certain amount of energy yang dia dapat tadi, yang extra tadi, so that dia boleh jadi stabil semula. Macam tu. Okay, hopefully you faham. So when the electron yang ke atas ini, dia jadi unstable, so dia kena releasekan certain amount of energy. How many? It's up to that electron. Sebab kita tak tahu berapa hydrogen atom yang dalam tube tu. Mungkin ada 100 elektron yang pergi ke n equal to 4, tapi tidak semestinya 100 elektron yang dekat n equal to 4 akan turun dekat energy level yang sama. Okay, mungkin elektron ni hanya turun setakat ke n equal to 3. Mungkin ada elektron turun dekat n equal to 2. So it depends. Okay, elektron release berapa banyak amount of energy pun depends on the electron. So contoh elektron ni akan turun dekat n equal to 2. Barulah dia jadi stabil. When the electron release the energy yang dia release itu akan keluar dalam bentuk cahaya, dalam bentuk photon. Dan cahaya itulah yang keluar daripada discharge tube. Maksudnya proses kat dalam ni, apa yang berlaku kat dalam ni adalah elektron terima certain amount of energy, elektron accept ke higher energy level, elektron yang ke higher energy level tu tak stabil, dia turun bawah balik, dia release energy in form of photon which is cahaya, dan cahaya itulah yang keluar daripada discharge tube. Warna pink ni adalah cahaya daripada discharge tube, yang keluar daripada discharge tube. Cahaya ini kita akan letak slit cahaya halus lah yang lalu daripada slit ini. Cahaya yang datang daripada photon daripada discharge tube ini akan lalu prism separate into various components. Dia akan separatekan dia mengikut wavelength yang ada pada cahaya itu. Okay? Dan wavelength yang berbeza itu akan menghasilkan warna yang berbeza, dan bila kita letak dekat plate, inilah dia line spectrum yang awak belajar. Okay, so inilah cara penghasilan line spectrum for hydrogen atoms. Okay, now we are going to proceed to the next one, which is energy level diagram. Sebab tadi awak belajar elektron naik ke atas, elektron turun bawah, benda tu kita boleh ubah ke dalam bentuk energy level diagram. Before you go to the energy level diagram, kenal dulu term-term yang perlu ada dalam energy level diagram. The first one is the ground state, which is state of in which the electron have their lowest energy. Since you are learning about hydrogen atoms, so ground state for hydrogen atom is n equal to 1. Excited state is the state which electron excite after absorbing energy. Macam tadi Mida cerita, Mida tunjukkan gambar Tadi daripada n equal to 1 dia pergi pada n equal to 4. So n equal to 4 tu we call it as excited state. Energy level associated with specific orbit or state. Okay, so now I'm going to use energy level. When I say energy level, dia merujuk kepada orbit itu. Okay, this is the energy level diagram for hydrogen. Macam mana datangnya bentuk energy level diagram ni? Dia sebenarnya datang daripada keratan rentas ni. Dia ambil keratan rentas lukisan atomic model ni. Kan bentuk dia kan bulat-bulat kan, dia ambil keratan rentas sikit, dia tegakkan dia. Faham? Instead of you punya energy level berbentuk curve, dijadikan dia tegak. Keratan rentas ini kita tegakkan dia, jadilah bentuk macam ni, macam graph. And we call this one is energy level diagram. Y-axis adalah energy, dia tak ada x-axis, dia hanya ada y-axis sahaja. Okay, sebab ini adalah keranta rentas orbital tadi. Label lah, n equal to 1, n equal to 2, 3 and so on. Depends on the question. This one explaining the formation of line spectrum. Sama seperti apa Madam cerita dekat gambar line spectrum tadi tu. Electron at ground state, n equal to 1. Obviously sebab hydrogen atom, elektron dia memang duduk kat n equal to 1. Absorb energy then excite to higher energy level excited state. So, when the question asks you to explain or describe the formation of line spectrum, these are the point that you have to write. Cuma tadi Madam explain dalam bahasa ringkas dan pasar. So, here Madam tulis proper sentence for you to practice explaining the formation of line spectrum of hydrogen atoms. Electron at ground state and then dia akan absorb certain amount of energy. How much? Tak tahu. Okay? Sebab itulah awak akan nampak ada 3 sini. Contoh Madam gunakan 3 atom hydrogen lah. Okay, the way they absorb energy tu kan berbeza, maka dia akan excite ke tempat yang berbeza. Kena ada electron at ground state and kena specific n equal to 1. Dia absorb energy, kemudian excite to higher energy level. Ataupun you can write excite to excited state pun boleh, tak ada masalah. At excited state, electron become unstable. So the electron fall back to final energy level. Photon are emitted in the form of light with specific frequency or wavelength. Bila dia terlalu excited, dia unstable, dia akan release certain amount of energy. Contoh yang Madam beri ni, semua ni jatuh dekat n equal to 2. Okay, bila dia turun, dia release energy, semuanya akan keluarkan cahaya in the form of photon. Dan photon ini adalah cahaya yang dikeluarkan lalu dekat slit, lalu kat prism, maka keluarlah line spectrum. Oleh kerana setiap satu photon ni dia punya wavelength dan frekuensi dia berbeza, maka dia akan menghasilkan line yang berbeza lah.